In question 6, context is about a disease that occurs in 3% of the population, and trying to state assumptions that are required to model this with a binomial distribution. The two assumptions are, firstly, that occurrences of the disease are independent of one another. Now, in reality, what does that mean? Well, that kind of means that if your neighbour gets it, that doesn't necessarily increase the chances that you're going to get the disease. Okay, so the fact that you get the disease is completely independent of whether your brother or your neighbour or a friend gets it. Okay, and secondly, the probability of getting the disease remains constant throughout the population. You could think of this as if the population was literally the population of the UK, for example, then the chance of the disease occurring in a person in London would be just as likely as the chance that the disease would occur in a person in Birmingham, for example. In part B, we're now going to use the model to find the probability of exactly 2 people having the disease with a random sample of size 10. So that's to say that we're going to be dealing with a binomial distribution of size 10, so n equals 10 there, and the chance of the disease occurring in a person was 3%, so that's 0.03 as a decimal there. So that summarises the distribution we're going to use. What we're actually trying to find is the probability then of exactly 2 people, so probably that x equals 2. Now, as a formula then, let's do this one as a formula. So that's 10c2 times by 0.03, so the probability of success in inverted commas, the probability of getting the disease there, to the power of 2, because 2 people have got the disease, and then times by 0.97 to the power of 8. So that's 8 people that didn't get the disease, 2 people that did get the disease. Probability of getting the disease is 0.03, and therefore the probability of not getting the disease must be 0.97. So those two things have to add up to 1. Probabilities add up to 1. Okay. Now, if you put that through your calculator, you then get 0.0317. 2 3 significant figures, or 4 decimal places.